Graph Theory, Class 7, Video 3. In this video we're going to talk about non-planar graphs. Recall, a planar graph is any graph that can be drawn without edge crossings. And in previous videos we did a bunch of examples looking at planar graphs, calculating the number of vertices, edges and faces. And it's perfectly natural to wonder, well, is every graph planar? Like, is it possible to take any graph and redraw it so there are no edge crossings? I mean, it might be difficult and it might take a lot of time, but is there always some arrangement of the vertices and edges so that there are no edge crossings? Well, no. The answer is no. It's not always possible. And in particular, I can give you these two examples, and these examples are very important examples. In a lot of ways, these are like the seed of all the non-planarness in the world. Like, all the non-planar graphs are sort of born from these two graphs. And that sounds like nonsense, but it's actually based in reason, okay? So, what do I mean by non-planar? Let's look at the first graph right here. You notice it's got a bunch of edge crossings, okay? And I claim that it's impossible to draw this graph without at least one edge crossing. So you can try and redraw it with as few edge crossings as possible. Like, you could draw it like this, and then I need to add an edge there, and I need to add an edge there, but I still need this edge here. So it still has one edge crossing. Okay? And you can try any sort of arrangement you want, and you'll never be able to do it without at least one edge crossing. Same with the graph on the right. You can try and redraw this without edge crossings, but it's just impossible to do it without any edge crossings. And in general, proving that it's impossible is not an easy thing to do, because if you think about what you're being asked to do, it's quite a lot. I'm asking you to prove that out of the infinitely many different ways of drawing this graph, all of them have an edge crossing, right? Out of the infinite possible ways of drawing a particular graph, no matter what you do, you're always going to have an edge crossing. So in general, it's very difficult to prove that a graph is non-planar. It's easier to prove it is planar, because to prove it is planar, all you need to do is draw it without edge crossings. To prove a graph is planar, just draw it. Just give me an example of how to draw it without edge crossings. But to prove it's non-planar, you have to prove that out of all the infinitely many different ways of drawing it, they all have an edge crossing. So I won't really be asking you to prove that a graph is non-planar in this course, because it's a bit much to ask. But you could reasonably be asked to prove that a graph is planar, okay? And I expect you to remember that these two examples in particular are non-planar, okay? And you can use this theorem to deduce that other graphs are non-planar as well. Okay, so what do I mean by this? If I drew a graph, a really simple example, so if I draw this graph right here, and then I just add a bit to it, like this, okay? So I'm randomly just adding bits to it, like this. Well, it's still non-planar. Okay, it's non-planar because this bit here is non-planar, and by adding extra stuff I can't simplify the graph, right? By adding extra edges and vertices, like, at worst you make it more difficult to be planar, but you can't make it more likely to be planar. So this is still non-planar because it secretly has this archetypal non-planar graph living inside it. Okay, so this is a non-planar graph because it has this pentagram living inside it. Okay, that's the end of this example, and that's the end of this video.